Multiplying polynomials by monomials is the title of our lesson today on page 158. It is not much different than multiplying a 3-digit number, 4-digit number by, say, a 1-digit number. Okay, this is just for you guys to kind of get an idea what we're doing. If I were to multiply 612 by 2, the answer, of course, is 4, right? The answer is 4, right? That's the answer. 612 times 2. The answer is 4?
No.
No. Why? Why isn't it just 4?
I do one step.
I only multiplied by one piece. I did 2 times 2, but I didn't do this piece or that piece, right? So in order to have a complete answer, you have to multiply the 2 by each piece in that big number, the 3-digit number. Almost like you're distributing is exactly right. So 1,224 would be a better answer than 4. What we're learning about today is that exact thing. Let's start with example 1. Example 1 is x times x plus 3. Now you might not see the similarity just yet. Hopefully I'll be able to show it to you. What we've got here is let's call this a 2-digit number, even though it's not. I'm just kind of trying to get your mind to think about it, being multiplied by a 1-digit number, which means each piece within the parentheses has to be multiplied by the x that's on the outside. Okay? One way of doing it is distributing, as Percy said. First, multiplying the x by the x, which is x squared. X times x is x squared, not 2x. X is basically x to the first, and so is that other x. You can kind of assume that 1 is the exponent there. And x1 being multiplied together, you add the exponents and you come up with x to the second. X times 3, and both of those are positive, is a positive 3x. And that is the answer to that multiplication problem. Now you can do it in a similar fashion to this, and it looks something like this. Instead of justifying that second number into the right, the letter, the smaller letter, gets justified to the left. And it really doesn't matter. You could technically put this under here, but it just seems like putting it on the left is the more commonly used way. So same kind of thing though. X times x, x squared. X times 3, 3x. And you get the same answer. Okay? Either one of these techniques is useful for all of the lesson today. Example 2, and as we continue with the lesson, it doesn't get any more difficult. It maybe gets bigger. It maybe requires you to multiply a bigger number by a monomial, but the steps don't change. Example 2 is negative 2x multiplied by 4x squared minus 3x plus 5. Okay? I happen to like the distributive method, but you can, of course, do the stack method too. 2x is going to get multiplied by each of these 3 things to make sure that you have the correct answer. A negative 2x by a positive 4x squared. Negative 8, x, x cubed. You guys see how I came up with that? Negative 2x by negative 3x. Negative times a negative is a positive 6. X squared. The last piece, negative 2x by 5, a negative by a positive is a negative. And your answer should look something like that. If you wanted to stack it, put the large polynomial on the top. 4x squared minus 3x plus 5, and put the monomial on the bottom, justified to the left. start with that left-hand side, and you end up with negative 8x cubed. The next piece, positive 6x squared. The last piece, minus 10x. Same answer, just a different way of doing it. Either way, I don't care which way you do it. Example 3 is fundamentally the exact same thing as example 2, except this time we've got some extra variables involved. Instead of just being x, we've got xy. The technique does not change. Okay, here we go. I continue to like to do my distributing, and I even do draw these little hoops when I do it myself. That way I remember which one to do, and I make sure I do each one. 5 times 3, that's 15. That's the number. And then x, you get x cubed. Now, there is y squared here, but there's no y here, so that means the y squared doesn't change. It's still y squared. Okay? Continuing, 5 times negative 4 is a negative 20. Yep. X and x, you get x squared. Y, and another y, you get y cubed. Last one. 5xy squared by y squared. Remember, if there is no coefficient, then you can put a 1 in front of it. Okay? So 5 times 1 is a positive 5. X times, well, there's no other x, so the x just stays the same. Yep. Y to the 4th. Okay? And I could stack it for you, but I think you get the idea behind the vertical. All right. Now, this is just us simplifying a few examples, but example 4 is where we actually have these types of scenarios equaling something, as in it's an equation. So it might look like this. We've got n times 2 minus 5n plus 5 times n squared minus 2 equals 0. And we need to solve for n here. If they give you an equal sign, that means they expect you to solve. Find out what the variable is. In order to ever solve an equation, you always have to simplify it to the point where you get a variable on one side equaling something else. Well, in order to get there, we have to follow the order of operations, and if you don't remember them, they're in the back of the room. But the first step in the order of operations is always to resolve anything in parentheses if possible. If you can't, then you look at exponents. If that is not something you need to do, you multiply. So we're going to start multiplying. N here and here, and 5 here and here. Okay? So n times 2 is 2n. N times negative 5n is negative 5n squared, right? N and 5n. Continuing, positive 5 and n squared is positive 5n squared. And positive 5 and negative 2, which is negative 10. All of that still equaling 0. Once you've got it fairly simplified, you want to collect all your like terms. The n squareds, if you add them together, what do you get? 0. They cancel themselves out. Yep. The property of opposites state that a negative number added to its opposite equals 0. So those two cancel each other out, leaving us with 2n minus 10 equals 0. We want to have variables on one side and numbers on another. So let's add 10 to the other side, which gives us 2n equals 10. Divide out the coefficients so that I have n by itself. Okay? This is just a bunch of extra work to get you to this spot. Okay? That's all it is. How you guys feel about this so far? Okay. All right, I'll get this thing uploaded. I'll let you guys get started.